Right now, in the drought-stricken suburbs of Arizona, multi-billion-dollar construction projects are being frozen in place because there isn't enough water to mix the concrete or sustain the workforce. But here's what doesn't make sense. North America sits on the largest source of fresh surface water on the planet, the Great Lakes, which contain enough water to submerge the entire continental United States under nearly 10 feet of depth. Because this isn't really about a lack of water, it's about the brutal reality of physics and the terrifying energy cost of fighting gravity. And that system, the way we move resources across a continent, is starting to break in a way that affects every grocery bill, property value, and industrial supply chain in the country. By the end of this video, you'll see what's actually happening when we try to pipe our way out of a crisis, why the world's most ambitious water projects are currently hitting a physical wall, and why the era of limitless geography is coming to an abrupt end. This is Tomorrow Explained. I'm Dennis Lisak. We explore the systems shaping the world just ahead of us. Consider the great man-made river in Libya. It is arguably the most expensive, most ambitious water project in human history. A network of pipes 13 feet in diameter buried under the Sahara Desert. It was designed to turn the desert green by pumping water from ancient underground aquifers to the coast. It worked, until it didn't. Today, as the system ages, the cost of maintaining the pressure required to move that water is becoming higher than the value of the food it grows. We are seeing a similar signal in China's South to North Water Transfer Project, a $70 billion endeavor that is struggling with the simple fact that water is incredibly heavy and moving it uphill requires more energy than some small nations consume. To understand why this is a systemic failure, we have to look at the hidden system of weight and energy. Water isn't like oil. Oil is worth enough per barrel to justify complex 1,000-mile pipelines. But water is heavy. 1 cubic meter weighs exactly 1 metric ton. If you want to move it from a wet region like the Great Lakes to a dry region like Phoenix, you aren't just moving a liquid. You are moving millions of tons of mass across mountain ranges. Modern life runs on systems you never see until they stop working. We've spent the last century pretending that distance doesn't exist, as long as we have enough cheap electricity to power the pumps. But the system is shifting. For decades, we relied on fossil water, aquifers that took 10,000 years to fill, and cheap energy to move surface water. We built the California Aqueduct, which is the single largest consumer of electricity in the state of California. But here's the problem. As our energy grids become more strained and our water sources become more depleted, the cost per drop is skyrocketing. We are moving from a world where water was a utility to a world where water is a luxury item. And this is where things start to break. The pressure isn't just mechanical, it's geopolitical. In the U.S., the Great Lakes Compact effectively bans the transfer of water outside of the basin. The states around the lakes realized that if they started exporting their water to the desert, their own ecosystems and shipping industries would collapse. That works until it doesn't. As the Southwest becomes more desperate, the legal pressure to break those compacts is mounting. But the physical constraint remains. Pumping water over the Rocky Mountains would require dozens of dedicated nuclear power plants just to keep the faucets running in Los Angeles. The early impacts are already here. We are seeing water bankruptcy in real time. In some parts of the world, it is now cheaper to move people to the water than it is to move water to the people. Large-scale agriculture is beginning to retreat from the desert. This is a massive shift in how we value land. I've seen a lot of debate in our comments about whether we should just build mega pipelines across the country. Given what we're discussing about the energy cost, do you think we should prioritize these massive infrastructure projects? Or is it time to accept that some regions simply aren't sustainable? Let me know your experience with water costs in your area. This failure cascades across every other system we rely on. When you can't move water, you can't cool data centers. When you can't cool data centers, the AI revolution hits a physical bottleneck. When you can't water crops, the global food supply becomes fragile. We are discovering that water doesn't disappear. It just moves somewhere you can't use it. This forces a massive reorganization of where we build factories, where we grow food, and where we buy homes. Here's the core insight we have to accept. The era of the engineered environment is hitting a hard limit. We cannot tech our way out of the weight of water. The reason we can't just move water where it's needed is that the energy required to do so creates a new crisis, a carbon and cost crisis that is ultimately more expensive than the drought itself. This is not a temporary problem. It is a fundamental realignment of human geography. Cheap food isn't normal. It's a temporary system that relied on ignoring the true cost of water. If moving water is a dead end, the only other option is moving us. Do you think we will see a great migration back to the Great Lakes and the Rust Belt within our lifetime? So what happens next? We are going to see the rise of water sovereignty. Regions with stable water systems will become the new economic powerhouses, while the desert cities of the last century will have to choose between radical conservation or managed decline. The question we should be asking isn't, how do we get more water? The question is, how do we rebuild our world around the water we actually have? This is Tomorrow Explained. Thanks for watching.